Thank you everyone for coming this afternoon. I have the pleasure of presenting to you how we do rapid large language model prototyping using OpenAI, of course, Databricks and Streamlit. But because I'm going to be spending now 40 minutes of my time talking to you, or rather at you, I think it's common courtesy that I also introduce myself a little bit to you guys. So I'm Alex. I'm from Germany originally, but now reside in Norway. I'm a mathematician by background, have been an academic for quite a number of years, and then when I was done basically moving around countries a lot, I switched to consulting, where I was working both as a software engineer and also data scientist. And while I was doing that, I basically discovered that there's a lot of methodology in software engineering and software development that we should really be using in data science projects. Now I am the head of cloud analytics and machine learning operation at Gjensidige, which is the largest insurance company in Norway. So you probably never heard of them. Yeah, on the personal side, I'm 36 years old. I have 2 cats. Of course, I brought pictures of them too, and I spend most of my spare time on a bike or on skis. So Norway is really the best place for me. And then I would also like to introduce our company to you as well. So we are the largest insurance company in the Nordic markets. We do both private and commercial insurance. It's a very strong brand built over 200 years, and the company is so inherently in Norwegian that you wouldn't be able to pronounce the name correctly if you don't speak the language. We have 2 million customers, which on a global scale is very, very little, but it's almost half the population of Norway, so on our scale it's quite a lot. So we have a 26% market share in the private market. We have very high customer loyalty. And we basically try and achieve this by being as efficient as possible in our operation. And that, first and foremost, includes an analytical and data-driven approach. So I tend to claim that the financial industry in general, but also insurance industry, that's the OG data-driven industry. All right, so today I am going to talk to you about how we do very fast turnaround with our prototypes, of very fast prototyping. And to do this, we use a method, because I believe that innovation is really rather a work smarter and not harder kind of situation. So it's not like you don't really need, if you have the right method, you don't really need to sit in a garage for 2 years and spend all your time until you're almost bankrupt and then hope for the best. So the particular method that we use is called the lean startup. But before I get into it in a bit more detail, I want to actually quickly dive into the history of LLMs to make a very specific point. And so we have this, if we look at this evolutionary tree of large language models, then really the only thing that I want you to take away from this is that they've been around for quite a while. So the release of the first kind of successful models goes back to 2018, and we also heard in the keynote this morning that researchers have, of course, been using large language models for a lot longer than we've known them in as a broader community. Then November 2022 came around. I remember this month very well, because that's actually when I started my job at Gjensidige. But most of you guys, I guess, you probably remember it for ChatGPT being released. And when it was released, it was quite the bang. Everyone was raving, everyone was jumping on it to use it, and everyone was like, wow, AI, I really want to use AI, it's a really cool tool. And so the news basically just, were full of messages about how ChatGPT sets records after records for fastest growing user base. So 100 million active users by January, and then also 13 million unique visitors in January. So that's for a new company, or for a company that people didn't really know or care about. That's really impressive numbers. And so the key message that I want you to take away from this is that if you want people to want AI, it has to solve their real problems. Because what you had basically with ChatGPT suddenly, you had a way of interacting with AI in a way that actually made sense to you as a user. So you could use it to have conversations about whatever you were wondering about. Basically that would have been published in the internet until September, September 2021. So it was pretty impressive. And also, but it's not quite enough to solve people's real problems. If you want to do innovation, you also have to do it fast. So I can't really be like advertising a product and then take half a year to release it to you, because then you're gonna not be interested anymore. And so this is what the lean startup method basically promotes. So the lean startup is a book by a guy called Eric Ries. The picture has cut off the name, unfortunately, but he makes 2 points. And the first is that a startup is really any kind of human institution designed to create a new product or service under conditions of extreme uncertainty. So that's the first point. And then the second point that I added as a side note is also that a startup it doesn't have to be a new company, it doesn't have to be a startup company, but it may well be a team or a product within a large and established organizations. And so we have this, but we have this phenomenon with startup companies in particular, and that is that about 90% of startups fail. Why is that the case? Well, I think it has a lot to do with this statement, where we said a startup is a human institution designed to create a new product under conditions of extreme uncertainty. So it's this point of under extreme uncertainty that leads to basically classical methods of business analysis to fail. So you're trying to analyze what your market is going to be and who your user is going to be, while you actually have no way of knowing who your users are going to be and what they actually want and what your market is going to look like. So this is why Eric Ries came up with this method called the lean startup. And at the core of it, it's relatively simple. It introduces a build, measure, learn cycle, and your goal is to iterate through this cycle as fast as you possibly can. And you do this by first generating some ideas. Of course, if you want to do innovation, you need some ideas. And the way you do this is you develop a falsifiable hypothesis that results in validated learning. So this is a point that I really like because, as I told you earlier, I'm an academic by training. So coming up with hypotheses is basically what I've been trained to do for a long time. And if you come up with a very concrete hypothesis, it also means that you can test it, right? And this is what he means by validated learning. So you create a hypothesis that makes a clear statement of what you think is going to happen as a result of your product. And then you're going to design tests for this hypothesis so that you can then, with data, validate your learning whether this hypothesis might be true or whether this hypothesis is false. And also another nice little feature of hypotheses is, or actually more like a gotcha of hypotheses, is that it's very difficult to prove something for certain. It's so much simpler to disprove something. It's much, much simpler. To disprove something, all you have to do is show a counterexample. And then you've already disproven your hypothesis. So the easiest way to do this is by designing hypotheses that you can try and disprove. And then you can try and disprove your own hypothesis and take the learning away from that. So we want to define, to validate or falsify our hypothesis, we want to design a minimum viable product. Minimum viable product is a term that is used quite a lot, I would say, but it's often, in my opinion, it's often used wrong. So when people speak about MVPs, often what they actually mean is a POC, a proof of concept. You only have an MVP if you actually are testing a concrete hypothesis on how your users are going to behave, and if you actually test it with user feedback. Okay, so we have our hypothesis, and then we should write some code. So you basically just implement and deploy the simplest possible realization of your MVP. You want to spend as little time as possible coding. And then you want to release it to your users so that you can collect data. Aim for recruiting early adopter type users. So those are the kind of users who really have the problem that you're trying to solve. Because these types of users, they don't care if the design is nice, they don't care if everything already works seamlessly. But if you're solving like 70 to 80% of their problem in a way that is easier for them than their current workaround solution or not existing solution at all, then they will be happy to test your product. Yeah, and then we go through this loop several times, as much as it takes, to figure out what actually is the right solution to a problem that your users might have. In classic product development, this is usually not done. So what usually people do is you basically develop your product idea, and you develop it fully with all the functionality that you think your users will want. And only then do people move on to the next step of making it reliable and then usable and then adding a great design. And then there's a big bang release. But then if you do that, you spend a lot of time, basically, and you run the danger of no one actually using your product because it doesn't really solve anyone's problem. So what you do instead to be able to develop this minimum viable product that I've been talking about is you do a value stream analysis. So you figure out what does it actually take to get from a trigger, from a problem, to some value for my users. And this whole time that you spend from a trigger to a solution that gives value, that's your lead time. So really in this build, measure, learn cycle, you want to reduce lead time for any features that you develop. So you might have in the problem that you're looking at, you might have a first step, and then you might have a second and a third step. And it could be the case that there's a team that that has to carry out step number 1, and step number 2 is another team, and step number 3 is another team. And then that naturally creates a handover and wait time associated with that handover that you really could avoid if you follow this build, measure, learn cycle. So when you follow this build, measure, learn cycle and develop your MVP, then really what you do is instead of going all the way from the bottom to the top in a sequential way, so you iterate through all of these steps many times. So for your MVP, you go from functional to great design in the shortest possible time, then you add a next feature, go from functional to great design in the shortest possible time, and so on and so forth. And so this is basically what my team works with in our company. So we're enablers for exactly these kind of minimum viable products and testing basically new solutions that we can then spread to the analyst teams in our company. So usually what we do is we identify a problem, or that's really my job. I basically just talk to other people in the company and figure out what are the interesting problems to solve. Then usually 2 of my team members will enter a collaboration with the team that owns the problem, and together we'll develop this MVP. And also while we develop this MVP with them, we teach them everything they need in terms of best practices to be able to own their own solution afterwards. Then we pull out, and we're available for support in general for them. And this is actually kind of enablement for MVP, this way of basically supporting users and also developing their own startup type solutions is a method detailed in another book that I really like, and that's called team topologies. So really there's there's a bit of back to the roots reading books going on, but these two I really recommend. And so now we know how to develop a minimum viable product that we can then test. And if we want to develop one that uses large language models, then really probably we want to develop a chatbot. And so to be able to do that, we need a front-end solution that's very easy to use and very easy also to develop for analysts, for example. So we use Streamlit for that as a front-end for our lakehouse data. Why is that the case? Well, Streamlit itself is written in Python. All our data scientists, they work in Python, and as we've also heard at the keynote today, Apache Spark have been told many times by many, many users, Spark and Scala is nice, but all our users work in Python. This is also the case for us. So it makes it just a lot easier for us to teach people how to work with this tool. It's also very easy to use. So getting started with a front end, with a web app, takes very, very little code. In fact, the code that you see on the right-hand side, that's completely sufficient for a whole web app. And then limited customization is probably usually not seen as a positive feature, but it is in this case because it just helps you prevent distractions. Like for some reason, people love designing visual things. So when users develop a web app, you can quickly get lost in trying to optimize which color to use or how your components should look like. So when the possibilities for customizations are limited, then you just avoid distractions. And finally, integration with Databricks was very, very easy because we can just use the Databricks SQL connector for Python to set up the connections and quickly get our data. So overall, the architecture for those kind of solutions for us looks like this. So in the middle, we have the Streamlit app that obviously lives in a GitHub repo. And on the left-hand side, we have everything that happens in our Databricks lakehouse. So we use dbt for all data transformations. And so for this particular use case that we might be using data from catalog A and catalog B to create catalog C, and that is then the data source for our web app. And we use GPT-4 in Azure as our large language model. Okay, so now we know what this solution looks like on a more on a higher level. So let's look at some code for components of a Streamlit app. So to create a Streamlit app, you usually write this code that's called just app. It's a Python file. We set up on the left-hand side, we set up the layout of our components. And again, what you see here on the left-hand side is actually is all the code you need for an entire web app. But then I would just want to zoom into this auth component, which I've detailed on the right-hand side. So here we can very easily just use our Azure authentication to log in users. So it's very little code that we need in total. It's very easy to understand for our users. That's perfect. We need a little bit more. So when we are authorized, so we are now, if we're looking at the left-hand side again, as soon as the user is authorized, they should be able to see what we've called the chat component, the method underneath, where then Streamlit also has a really nice, simple way actually of creating a chat web app. So you just define the messages that your bot is supposed to send, and then it listens for user messages. And then we go into this method on the right-hand side where we answer the question. So a user will send a question, and in the method answer the question, we can then just call the OpenAI Python API to get the answer to that and then send that back to the user. So that's how you get this kind of chatbot experience with Streamlit. Finally, of course, we also need to connect to Databricks. So for that, we've just written a Databricks client that uses the Databricks SQL connector and then sends SQL statements to Databricks and then collects the answer back from us. Oh yeah, and I forgot the OpenAI client. We also need that, so we need to connect. We also have a Python API for that from OpenAPI, and that we can connect to with our API key. And then we can ask for a prediction from OpenAPI with the completion code on the right-hand side. So this is with all this code that fits on just how many slides was that? 4 PowerPoint slides. You have a complete ChatGPT web app. Okay, so with these tools, we then went on to actually investigate our problem, and that is developing an AI analyst. Because in insurance, as I mentioned before, insurance is a fundamentally data-driven business. So your journey as a customer with an insurance company might look something like this. So the insurance has created products and priced them, and then you would typically buy insurance. You have it, you manage it, and then you might at some point need to use insurance. And so there's many questions that we can ask ourselves that we can answer with data. So for example, how should we price this product or service? That's determined by data. Will the customer be on the phone be profitable? That's determined by data. Should we contact this particular customer for cross-selling? Can we process a claim automatically? Small fun fact, we do actually unofficially have the world record for the fastest paid out claim for a travel insurance claim. It took 1.8 seconds from the moment the customer sent the claim in our app until the money was in her bank account after she didn't get her luggage after a flight. And then there are many more questions that we can answer. And so because we are so data-driven, we also have a very large community of analysts in our company, more than 200 analysts, data scientists, data engineers. And so we have an internal conference every year that we call the Analytics Summit, where last year we had a panel discussion on AI. And as a side note, in our company, we don't need any quota for an expert panel on AI to be female only. That just happens. So I'm sitting in the panel in the middle on the right-hand side, and to the left of me sits my colleague Irene. She is a chief data scientist in private insurance. And when the question came up of whether we are scared that AI is going to basically take our jobs away from us, she didn't hesitate to answer, "What do you mean? No, I'm like super excited for AI to do all the boring jobs that I don't really want to do, so that I can just do the more exciting jobs." And so I figured, oh, that was an interesting response, and so I went up to her after the panel discussion and asked, like, "Oh, what did you actually mean? Like, what are these boring tasks that you have to do that you don't want to do anymore?" And so, as it turns out, because we are such a data-driven company, also our decision makers obviously need to make their decision and want to make their decisions based on data. But most of the decision makers, they're not fluent in SQL. They don't know how to write SQL code. So what happens basically is that they sit in a meeting somewhere, need some numbers, they send a message to a data scientist or an analyst or a data engineer, they don't get a response, so they send the same message to 5 more. Probably don't get a response from either of them while they're in the meeting. Meanwhile, the data scientists that have gotten the message at some point will see it, will need to interrupt the work that they've been doing to then do this trivial SQL extraction and send it back to the person who requested it. And after that, they need to get back into the work that they've actually been doing. And psychology is very clear on how when you've been interrupted on an important task, then it takes about half an hour for you to get back into the task. So we did some small back of the envelope calculations and figured out that if each data scientist gets one of these messages a week, then we have 10,000 of these requests per year. Maybe you have to send some messages back and forth to actually figure out what the person actually wants, because believe it or not, the question, how many customers do we have, is the most difficult question to answer in our company. It really depends on who you talk to. And so then that means we spend about 5,000 hours a year on these trivial tasks that no data scientist actually wants to do. So I figured, oh, this is great. This is a problem that we can solve, I think. Let's see how we would go about this. And so we went ahead and made this value stream analysis that I showed you in theory earlier, which starts with someone in the business needing to make a decision. So they send a message request for data to the data scientist, who then needs to run the SQL based on that request. And so then the business can use that data and we can create value. And probably there's some back and forth between step number 2 and step number 1, but that's not too important. And so as soon as we'd defined this problem and identified what we wanted to do and what we wanted to solve, like most development teams, we first came up with a name and a logo for our solution. So you get to meet Eglev, our AI analyst. And the history for the name is also quite nice, actually, and it's a very personal story. So Eglev is an old Norwegian name, and it's the name of Eirín's grandmother. And so the face that we gave Eglev also is a picture of Eirín's grandmother that we modernized with AI. And then also the name Eglev means, in Norwegian, it means I live, which is also a bit of a funny name for an AI. So we were happy with that, and then we started actually working on the problem. And then we quickly figured, okay, so we want to have an analyst that can access our entire data warehouse and do SQL extractions, but our data warehouse is huge. So here's an extract of the DBT lineage graph of our data warehouse, and it's only a small extract. So you basically, if you add 5 more of these slides at the bottom and 5 more of these slides at the top, then you have about the scale of our data warehouse. So that's a bit of a challenge. But then Eirín said, well, 80% of the requests can be answered with just 2 of our star schemas. So here it's really, really good to have the users of your solution with you in the team who can give you this domain expert knowledge and tell you, well, we don't need to worry about the entire warehouse. We just solved this problem for 2 star schemas. Then we have solved 80% of the problem, and then we can actually figure out if people actually then want to have the solution, then we can add more data to it. So then we had an MVP scope for Eglev to solve our real problem fast, with the objective to demonstrate that a large language model can write correct SQL against our lakehouse data. So we limited the access to 2 star schemas. We keep the user interface very simple as possible with the Streamlit. We recruited a number of first adopter type test users for our private preview. And then we widened, we widened data access gradually and added also more functionality according to our user feedback. So the architecture for this actually is really simple. We start with the user asking a question. Could be, for example, how many customers do we have? This very loaded question that has about as many answers as there are people in the company. We need then to create an SQL, which we do using GPT and a prompt that we designed. Then we need to run this query against Databricks in Azure. And we need to generate an answer back in natural language. And then we're already done. So that's all we need. OK, so how did we actually implement this? So if we look at the first step in our architecture, the user asks a question, how many customers do we have? And we want to create an SQL from that. So there we really just are in the domain of the Streamlit front end that I showed you earlier. And we basically, one of the methods that we jump into once the user has asked the question is basically one that we called answer the question. So we just pick up the question from the front end and take it with us into the next step. And here we basically want to generate the SQL, hop into the next step of our architecture. So in this next step of our architecture, we then connect to the OpenAI client, because here we are in the step where we want to ask OpenAI about what is the answer to this question, and send it with a system prompt that we basically predefined that sets up the context for the question and also connects to the data warehouse documentation. So we get the SQL query back as a response, and hop into the next step where we give both the question that the user asked the SQL query with the result back into another instance of GPT to then generate the answer, which is here, yes. And then we have it. So we have another instance of the model that basically just answers the question based on what the question was, the SQL that you got, and then the result from the SQL. And then with that, we've implemented our entire architecture. And so, of course, I have a demo for that. So it's a video. And I've never quite nailed the speed of these videos. So the video is a little bit fast. So I'm going to stop it at the appropriate moments and explain what's going on. All right, so now we're typing a question. In this case, let's start it again. How many Tekna customers do we have? And so this is basically just a group that gets a discount on our premium. It's a question that I like to ask as a test question. The algorithm is working on it and gives us a response back in natural language, 83,000 something Tekna customers. And so then it also tells me where it created the data from. And I can, if I want to, look at the SQL that was created. Because maybe I am an analyst and I'm testing the solution and I want to check that it's correct. And then I can also, like in ChatGPT, give feedback. Of course, I want to ask some more complicated questions as well, not just how many of something do we have. So in this case, we are asking the question, how many customers do we have per customer score profile in private ordered by customer score profile. The algorithm is working on the question and sends the answer back in a nice human-readable format. Again, I can look at the SQL if I want. And maybe I want to give some feedback. This was a great answer. This is useful for us. And that's and with that, we basically, within just 2 weeks of development time, we developed this MVP, sent it into private preview, have gotten very good feedback. Now, actually, it's not only business people who use the app, but it's also analysts who like using it a lot because, so for example, like me, I'm still very new in the company. I'm very good at writing SQL code, but I don't know where to find anything in our data warehouse. So I can just hop on Eglev as well and ask to find out where I can find my data. So we've had it in private preview now for a little while. We did this actually back during the winter time because we weren't patient enough to wait for Genie to come out. But now we've just released it into general availability, and there will be a party for it next week. And with that, I'll thank you for your attention. And if you have any questions, I'll take them.